So we have arrived at the beginning of what statistics, in my opinion, really is all about, especially in application sciences like public administration. And what statistics is an ability to talk about both the inference of data on real world and the ability to manage what that data implies, right? And so far we've been doing something that was very similar to this. This objection is to find confidence intervals. We weren't sure, but we wanted to be somewhat sure that mean is here, or the population proportion is here, or the population variance is somewhere, right? And so what we're going to do today is we're going to start talking about hypothesis testing. The hypothesis testing is exactly what it sounds like. Is we are going to test whether or not a claim is valid. Right. So we have two things to consider. One is what is valid, and one is what is a claim. Most of the things that we do are stated in very, very, I want to say English terms, very English terms. For example, like this. Most people meet their spouse in college. I mean, that's why colleges exist. Right? They exist. They don't exist to get your education, because you need to work most of the time to pay for that education, right? So the only reasonable conclusion I go is it's a breeding ground to meet people. Right? Problem is, this sounds great in English. It's problematic in mathematics. Because how do we deal with this? Right? Are we talking about proportions? Are we talking about means? Are we talking about variation, variance, standard deviation? Right? What is this? I would like to have a symbol, preferably an equal sign and another symbol or another number. So what is this? Is this proportion, mean? What is it? Yeah, but it's asking about proportion. It's asking about a mean. What is it asking about?
So most is like a mean, average. Probability.
It's probability, right? It's proportion. Because this, right? This is asking for proportion. Well, if it's asking for proportion, right? And it's obviously talking about most people, right? So we are talking about population proportion, yes? And then it says most. What does it mean to be most?
Average. Majority.
Which is numbers. I like numbers. Letters and numbers, not words. One.
Greater than.
One. Okay. 50% is right in the middle, right? If you are splitting rent, and the rent is $1,000, right? And you have to pay $500.01. Are you paying most of the rent?
Yes.
Right? So we want 50 and we want bigger. Well, so, right, percentages, again, I have an odd relationship with percentages, but that. Do we care if they're meeting the spouses in college? Do we care? Once we start to remember things, do we care about all the other fuzzy things? No. We're caring about most. Right? That gets us the rest of the way. Okay, how about this? How's that? The average driver on H1 drives at 57 miles an hour. It was 56 until I moved in. That's more like 57.
Does it have to be greater than 50?
No.
But we're only looking for one variable, 50%. Or
Well, no, in this case, we are checking most, so it has to be greater than 50, right? For this specific example. Could be less, right? Half, right? You can use different descriptors. Like, for example, here it was most. Here, it's a statement, right? And in mathematics, a statement, a sentence, has an equal sign. Because what are we talking about here? Are we talking about proportion or are we talking about means? Means. And again, drivers on H1, we can collect the population of people that drive on H1, which, since Hawaii is such a big state, is like everybody. Right? So we talking about population mean. Right? Equals. So when we are talking about hypothesis testing, we are talking about a claim, so a statement. We're going to be checking, right? So we have to quantify it first, and then we have to check it. So this leads us to back to rare event rule. What was the rare event rule? Yeah. If your buddy that never got laid tells you that going to the bar guarantees you getting laid, you're probably going to waste your time going to that bar. Right? This is saying, so if the probability of an assumption occurring is very small, then the assumption is probably I'm going to politely say incorrect. So if the probability of an assumption occurring is very small, then the assumption is probably incorrect. It's a gentle way to put it. There's no way it's happening, bullshit. Okay. So let's look at an example. So we take 100 couples and we make this assumption. Actually, let's do it differently. Let's make a claim. So we have a claim. If used, maybe we should say sample of couples was studied, and this is a drug company. So drug company. So a drug company says, hey, if used, the drug gives at least 80% chance of having a girl. We know that there is natural ways of natural selection to increase chances of having a boy or a girl. But there's also drugs that do it. Because, why would you want to have a natural selection? Let's push it one way or the other. I mean, China has one kid policy unless you're having a girl, right? Because then you can have two kids. You murder the first one. So we have a claim, right? We have a drug that does it. We study 100 couples. Okay, what are the two outcomes we can think of? Well, no. One is the drug works, the one doesn't work. We are past that simple statistics where we can have a boy, a girl, and a unicorn. Right? We are doing with two cases. So one is 52 couples, head girls. Two is 97 couples, head girls. Let's look at those two cases. So a drug company made the claim that if used, you get at least 80% chances of getting a girl, which I think is not bad of a chance. And then we tested it. We talked to 100 random couples that took the drug and 52 head girls or 97 head girls. Right? Those are the two outcomes. And so, how do we test it? Sorry? Well, I'm not asking the actual procedure, but this is a mental exercise, right? If I told you that out of 100 couples, 52 head girls, would you be surprised? Right? Even though we are expecting 50-50, right? The chances of getting 52 out of 100 is still quite feasible. How? 54, 55. On the other hand, if I told you that we have 100 couples and 97 of them had girls, right? What would be your first question? Right? First of all, that's highly unusual, right? We are expecting 50%. So this is highly unusual to get 97 out of 100 to be couples, right? And questions, are they using a drug, right? Could this happen naturally? Could you select 100 couples and 97 of them will have girls? It could happen, but it's very, very rare, which goes back to the rare event rule. If something is really, really rare or really, really unusual, or there's a chance that it's very, very small, right, the assumption is probably wrong.
Is 97 considered a small percentage, or are we looking at 99?
No, we're looking at the chance of getting 97 out of 100 with a probability of 50%. It's like flipping a coin. Can you get 97 heads out of 100 flips? Yes, you can.
Very rare.
Just I wouldn't bet on it, right? So what we are saying is, hey, is this outcome or this sample different enough from the claim to say that the claim either works or doesn't? Right? We are starting to match things up and telling us if they work or not. So that's part one. Part two, hypothesis testing is like the law, the criminal law. Anybody watch criminal police type of TV shows or movies? Do they say you're innocent or guilty?
You're innocent until proven guilty.
Well, innocent or proven guilty, but after and the sentencing, right? They say you're guilty and innocent, or they say guilty and not guilty, right? They don't say innocent. So in our case, we cannot prove claims right. We cannot say this is true. We can say, hey, this is complete false, right? Or we could say, hey, we don't have enough evidence, right? Just because I didn't catch you stealing doesn't mean you're not a thief. Just because I didn't catch you cheating doesn't mean you're not a cheater, right? If I catch you cheating, you're a cheater, I got you, right? So in hypothesis testing, we are approaching the same concept of guilty or not guilty. We cannot do innocent. So let's look at the parts of hypothesis testing. So first thing is we have a hypothesis. So we're going to start with, we have a null hypothesis versus an alternative. Right? We can make a statement, hey, at least 60%, or sorry, at least 80% will having a girl. Or I can say alternatively, it doesn't work. Right? So I have two sides to argue. And so the null hypothesis we define it as H sub 0. H sub 0. And it's a statement. So it states that a population parameter is equal to some value. When we're talking population parameters, we're going to be talking about proportion or the mean. So it states that some population, well, examples. That's the notation. The null hypothesis is that the mean equals to 51, or the null hypothesis is that proportion is equal to 0.7. That's how we state it. H sub 0. So it's a subscript. Okay. So how do we test it? In mathematics, an equal sign means it's a statement, it's a sentence, right? It's a full thing. So we're going to start by assuming that the null hypothesis H sub 0 is true. We have to start somewhere. So let's assume that it is true. Let's assume that the drug works. Then I'm going to use the evidence, which is a sample, to reach a conclusion. I can fly. Great. Start jumping. You crash land, means your statement was false. Right? We can reach three conclusions. Statement I can fly, right? Or statement I can drink a gallon of milk or 2 gallons of milk in one sitting. That's a claim, right? I'm saying I can do it, so everybody can do it, right? So we all can drink 2 gallons of milk in one sitting. Mu equals to 2, right? It's a statement. Well, I could check, right? I could give each one of you a gallon of milk and we can sit down and chug it.
No.
We've seen the YouTube video, that doesn't end well for anybody. So,
Unless you
I adore milk, so we are not friends anymore.
first statement, you said you could fly, right?
Yeah.
And then you said you crash land.
Yeah, if I crash land, right? If I tell you I fly and I crash land, well, what do you do? Well, you reject my statement, which means you reject H sub 0. Right? If I say that the average grade of a person in this class is a D minus, right? And then you start pulling up your report cards, and we sample this class, we sample 5 people of this class, right? And there is no a single D inside. Well, you're going to reject my claim. Right? I'm the best teacher ever because my reviews are spectacular. Well, you can pull up reviews for somebody else's class and they're getting good reviews. You reject it. Right? So we have a very clear statement saying, hey, I have enough evidence to prove H sub 0 is wrong. It's a very simple thing. There was a statement, a claim made, right? We assumed it was true. We tried it. It failed. We reject it. Right? You start dating somebody and they're saying they're super rich, and you open one couple of their bank statements and there's like $0 in the balance, right? You reject that claim. What's the other alternative? Well, we could fail to reject. Right? I assume it's true, but I really, really want to prove it wrong. Fail to reject. Well, I don't have enough evidence to prove H sub 0 wrong.
Is it going on now?
Sorry?
It's the last time.
What?
We're doing statistics.
That's a lie. I reject your hypothesis. So we can fail to reject. Why do we fail to reject it? Because we cannot accept it to be true. guilty, not guilty, but I cannot prove that you're innocent. And this is the biggie, because these are the only three choices you have, right? And the last one is not really a choice. So when somebody makes a statement, you can either prove they're wrong, or say, hey, I don't know, could be true. I have an inkling that it might be right, but I don't have it. Why? Because we take a sample. We are not talking about checking the whole population. If I told you that 1 out of 3 people in the United States can drink a gallon of milk in one sitting, you could ask 20 of of the people in this college, right? None of them can do it. I'm gonna say that's a pretty good guess that that I'm rejecting. But if at least one of them can do it, you're like, well, there is possibility, right? You cannot say that I was right saying 1 out of 3. You don't have enough information to do it. All right, so we have, that's hypothesis part. Let's look at the other side. Okay, so that's null hypothesis. Well, what's the other side? Well, the other side is the alternative. And we define it as H sub 1. Some books will refer to H sub 0. But then we have ho-hos and ha-has, and that's just awkward. Right? It's like Christmas coming. So we're doing H sub 1. That's alternative hypothesis. What's alternative hypothesis? Well, alternative Booyah shakalaka, right? Alternative hypothesis H sub 1 states that the parameter, and we are still talking about population mean or proportions, right, has a value different than H sub 0. Alternative hypothesis say the opposite. So you make a claim, I state the opposite. One is alternative hypothesis, the other one is the null hypothesis. What does it mean different? Right? When we say null hypothesis states it's equal to something. So what's the opposite of equal? Well, we have 3 choices. Something could be smaller than, greater than, or just plainly not equal. And so examples of it. Right? Notation wise, they look.
alternate hypothesis for notation has it as HO and then
Which page are you looking at?
47.
47. Alternative hypothesis is H1.
Yeah.
Oh, that's an error.
Oh, the notation is in there?
Yeah, the notation under alternative hypothesis in that low section should be H1.
So it should just be like how it is in the word?
Yes,
Okay.
I apologize. Page 47, second paragraph. It says H sub 0. It should be H sub 1. Good catch.
After notations?
Yes, and the line above it, right there towards the end. I apologize. Made a mistake. All right. So now we have those two statements. We have a null hypothesis and we have an alternative hypothesis. I just told you we cannot prove the null hypothesis. We cannot prove H sub 0. We can disprove it, right? We can say it's wrong. But if we say that H sub 0 is wrong, are we telling that H sub 1 is right? So we can indirectly prove statements, but they have to be stated as H sub 1. Right? So if we have two people, right, and one of them is a killer, can you prove either one of them innocent? No. You can prove one of them guilty and the other one not guilty. But if you prove one of them guilty, right, then the other one is innocent. We're doing it through one extra step. Legal.
The bar exam.
Yes. I did warn you that statistics is a fun subject. So we. Well, the victim. You killed somebody, right? So
So he can't be the other.
yeah, well, he cannot be in the equation. So we prove things indirectly. Right? We know that H sub 1 is the opposite of H sub 0. Yes, because it states the exact opposite as the null hypothesis, right? So null hypothesis has some equal statement, and then we have alternative hypothesis says the exact opposite. If we reject H sub 0, we stand up in court and go, bullshit. Right? We prove H sub 1 right. Because you have two choices, right? Either one or the other. So if I prove one of them, if I prove H sub 0 wrong, then H sub 1 should be right. Right? On the other hand, if you fail to reject H sub 0, if you fail to reject H sub 0, right? Welcome back to the military. If you failed, you failed. Right? So we either reject it and we prove H sub 1 right? Or we fail to reject H sub 0 and we can't say anything about H sub 1. Thus, we should note that if you want to support a claim, so if you want to support a claim or prove it right, you must state it as H sub 1, the alternative hypothesis. You cannot state it as H sub 0, because the only thing you can do with H sub 0 is reject it, or fail to reject it, but you can only reject it. So if you're running a project for one of your other classes, or you have something that you need to do for work, and if you want to make a claim and then prove it the claim right, you have to state it as an alternative hypothesis.
So we have to work out the H sub 0, and if it doesn't work out, then you can't.
Well, no, we only do work on H sub 0. In this stage of class, we only work on H sub 0. So you have two claims. You have the null hypothesis and the alternative hypothesis. So you say a claim and the opposite. One of them is the null hypothesis, one of them is the alternative hypothesis. Yes? Yes. You pick up the one that is H sub 0, and that's the one you're going to work on. And the only thing, the outcomes of that could be you either fail to reject it or you're going to reject it. Right? If you fail to reject it, well, that's it. You failed.
Okay.
You know, small violin kind of thing. Right? On the other hand, if you reject H sub 0, if you reject the null hypothesis, that means you're proving H sub 1 right. Right? And you can state your claim in both as alternative hypothesis or the null hypothesis. You can say the average speed on H1 is 57 miles an hour, and that's a null hypothesis because it has the equality sign in it. Or you can state the average speed on H1 is larger than 57 miles an hour. And that's the alternative hypothesis. It doesn't have an equal sign, right? It has one of those three things. Or it's not equal 57 miles, right? If I make a statement, it's 57, you can either prove me wrong or say, hey, I don't have enough evidence to prove you wrong. If I say it's bigger than 57 miles an hour, right? Well, you're going to check if it is equal 57. But because it's not equal, then I'm assuming I'm right. Okay. So let's look at an example. Suppose we want to prove that the fertility drug works. Right? If we want to prove it works, how do we state it? We have to state it as H sub 1. Right? Well, we want more girls, right? So we're going to say, hey, H sub 1, saying the proportion of girls is going to be greater than 50%. Right? Yeah, I know it said 80, at least 80. I'm going to say it's bigger than 50. It works if I can skew the number of girls getting born, right? Which means that the null hypothesis is this one. Right? And I have the two statements, right? I'm going to work on this one. and I can reject it. If I reject this, then this is right. Right? This is the claim and the alternative. Right? If I reject it, the drug works. If I fail to reject it, I'm inconclusive about the drug. Right? I need more data. There's the usual excuses. I need more data. It's been inconclusive. My sample needs to be bigger. Right? There's a language for it. Yeah. Now, how do we do it? We're going to do in a second. For now, we are just getting comfortable with the terminology. So far, everybody's with me. Yes? Yes. Good. The challenge right now is figuring out that we have two hypotheses and we can only deal with one of them. So I suppose the next question will be, how do I identify one of them? Right? If I only can work with H sub 0, wouldn't it be nice to know which one's H sub 0? So how to identify? H sub 0 and H sub 1. Now, the process I'm going to present to you is laborious. And I highly recommend you do it anyways. The reason why it's laborious is because we are going to avoid making simple mistakes. It's very easy to jump straight to equations and screw up. So just bear with me. I'm going to do it slow and steady. I'm going to start by stating the original claim. Symbolically. We're going to follow that by stating the opposite. So we stated the first one symbolically, we stated the opposite as well. And here's the kicker. It all depends on where the equality is. Right, we know H sub 0, or the null hypothesis, is a statement, so it has to have an equal sign in it. So once we state one and we state the opposite, it should be very easy for us to pick which one is the null hypothesis, which one isn't. Example. The mean of fluid in a can is at least 12 ounces. My Z's are funny. Right? If you are a beverage manufacturer and you're selling 12-ounce Cokes, you really want to make sure there's at least 12 ounces, right? How many of you would get upset if you open a Coke and there's 13 ounces of Coke in there? Right? But imagine you open a 12-ounce can of Coke and there's like 10.5 ounces. Like it's a half a sip short. Right? That would piss you off. So we want to make sure that it's at least 12 ounces. Okay. So let's state it. We're going to restate the claim. So what is the claim?
Are we looking for the mean?
Oh yeah,
Mean.
at least. So the mean is bigger, equal to 12. Right? It says at least 12. At least 12 ounces means 12 or more. Right? So that's the claim. So let's do the opposite. What's the opposite of that? What's the opposite of at least 12?
Greater than
Less than.
or less than.
Less than 12. That wasn't so difficult. You're joking now. This is a killer on exams because you draw a blank, because you want to skip to all the other steps. By the way, for your homework, this is non-negotiable. Like, I don't see this on your homework, I'm not going to grade it. There's 10 problems, I think only 8 of them or 9 of them are, or there's 12 problems, only like 8 of them have hypothesis testing. Just write it for me. So the question is, which one is the null hypothesis, which one is the alternative hypothesis?
Alternative is the claim.
Where's the equality? There is no equal sign here. We need for equality, right? It depends on the equality. H sub 0 has an equality in it. Right? This has equality in it. So this will be the null hypothesis. Right? You look for the equal sign. The equal sign, the null hypothesis always will have the equal sign. Which would make this okay. So now we're going to restate it. So step 1 was to figure this thing out. Step 2, we're going to restate this. So let's restate it. We're going to say, hey, the null hypothesis, we're not worried about the claim anymore, or at least not for now. We're going to say, hey, the null hypothesis is mu equals to 12. Now, back in the good old days, you rewrote the whole thing, but nowadays there's a new trend of restating just the equal sign, because we are just testing if it's equal. Right? And h sub 1 is mu is less than 12. It's a Donald Trump's border. We don't care if you're on the other side of the border, right? We're caring if you're on the border or beyond it. We don't know much about the population. What we know is about the sample. So what we're going to do is next is we're going to take a sample and try this and see if it holds any water. No pun intended. But before that, we're going to do some more problems because I'm feeling we might need this. So I'm going to provide you with 3 statements and you're going to do exactly this for those three statements. So first statements, first is the proportion of male CEOs is greater than 50%. That's the first statement number one. Statement number two is the mean weight of babies is at most 8.9 pounds. And statement number three, the mean of IQ score is 100. All right, so what do we have for the first one? What's the claim?
Greater than or equal to 50. Or 0.5.
Greater or equal?
No, just greater.
Or,
Very careful. Just because I had an equal sign in the claim here doesn't mean it's always going to happen. So this is the claim. What's the opposite? Is that the opposite?
Less than or equal to.
Yes. You need to cover the whole range. You cannot just drop a number. Plus, if you have no equality anywhere, you're screwed. Right? Okay, so which one is sub-0, which one is sub-1? Which one is the null hypothesis? The top one or the bottom one?
No, the bottom one.
The bottom one. So so this one is h sub 1, right? And then we restate it. We don't touch h sub 1, so that's still greater than 0.5. But we restate the null hypothesis and we say, hey, all right, let's try the second one. How are we doing on the second one? The mean weight of babies is at most 8.9 pounds.
Would the claim be
Claim is what?
The P is less than or equal to.
P?
8.9. Or no, I'm sorry.
It's mean. It says right here, mean.
Mean is less than or equal to 8.9.
Okay. At most. It says mean at most. This is the difficult part of hypothesis testing. I'm going to tell you in all fairness, this is the most difficult part of hypothesis testing. Everything else is just z-score, t-scores, it flows. This is the difficult part because it's the setup. You screw up the setup, the rest of the question is, well, partial credit at most. So what's the opposite? Oh, the opposite is mean is greater than 8.9. So if I had to restate it, h sub 0 would be the top one, right? So mu equals to 8.9. And the alternative, I'm just going to get the IQ score later. Mu is greater than 8.9. And the last one, it was the average IQ score is, I think it was like this. The average IQ score is 100. That was the last example. So, the average, so claim is mu equals 100. So what's the opposite?
It's less than 100. Can it be more than?
Mu is what? It's more or less, but it's not equal. So again, h sub 0 mu equals to 100, h sub 1 mu not equal to 100. Are we having a mind blown moment? Mind blown! Apparently those jokes are funny because of my delivery. Because I'm a man with an accent. Okay, we good on this? I'm just going to hide it. Okay. All right, so, well, this class is called decision making, so let's make a decision. So how to make decisions? I'll do it on time. Plenty of time. Can we be certain about what the population is going to do? No, right? So we are running still in the this realm. We are running in the realm of confidence levels and significance levels, right? So when we are looking at significance level, alpha, right, what are the most common ones?
Of alpha?
Yeah. Well, the most common confidence levels were 90, 95, and 99, which means that most common ones are 0.1, 0.05, and 0.01. I'm just going to use them like this. Make points here. Now, when we talk about alpha, right, when we're talking about confidence level, we talk about critical values. So in our case, right, in our case, critical values would separate the reject region from the fail to reject. So separates. So critical values separate the reject region from fail to reject region. So if I had alpha equal to 0.1, what would be the critical value, z, for that? Well, it would be 1.645, just like before. Right? We haven't introduced anything new here. What we are trying to talk about is, we talked about confidence levels, right, and confidence intervals. Nowadays, we are going to start talking about rejection region and fail to reject regions. Right? Is the sample providing data that is so far out that our hypothesis seems wrong? Right? Or is our data suggesting that the sample seems to be somewhat where we thought the population is, and we fail to reject it because it's not different enough? So this is where we are. I suppose that the question is, what's reject region? Rejection region. Well, rejection region is defined as how? Well, if our test statistic falls into this region, so we define the rejection region as, if our test statistics falls into rejection region, we reject H sub 0. Example, here it goes. In a situation like this, we would define this little section as rejection region, and we would define this as fail to reject. Sorry? What? Did you say sickening?
No, I said statistics.
Oh, statistics.
No, but also like this little note you have here, it says before you start doing anything else, draw a picture or lose all hope.
Yeah. This is what I said. I said it, and when I was editing parts of this with my dad, I was trying to tell him that picture needs to be drawn. He's like, then you should put something like this. And I just typed it in, and this is what it stayed. And it's going to stay there. Lose all hope, yes. Pictures. So in this case, right, we would look at it. So if we have a test statistic, and our test statistics, we calculate our test statistics, and our test statistics comes out to be 2, for example, we reject H sub 0. If our test statistics comes out to be 1.7, well, sorry, 1.2, it ends up over here, we fail to reject H sub 0. Right, so this is how it looks like. But before we start talking about this, we should probably talk about what are the test statistics. Right? I'm mentioning test statistics, like what the hell is that? So, test statistics. Right? Mind you, statistics is not hard, it should not be difficult, it should be life-altering, God-denying, soul-crushing alteration of your life. Like that's statistics. Grand moment of existence. I survived. So test statistics. We have proportion. And for proportion P, we're going to use Z, which is P hat minus P divided by square root of PQ divided by N. For means, mu, we have two choices. We have Z, which is X, over T, if. So you have one and the other. If population and standard deviation is unknown, we use T. If it's known, we use Z.
Oh, you said if it's unknown, you reuse T?
Yeah. Well, because we have, in this case, you usually have S, right? So if you don't know population. And here's, we're going to do one example, and then I'm going to do one note, and then we're going to move towards Monday. And the rest of it on Monday. How's everybody doing so far on this? So far, no major hiccups. Because this chapter tends to cause problems, at the end of chapter 5, I put in 3 worked out examples, step by step how to do it. There's some shortcuts here and there, so you're going to have to fill in the blanks, but there's actual examples in the chapter. Because this has been given previous problems. So, survey gave us this, a sample of 706 CEOs found 61% to be male. So we took a survey. 61% will be male. So we make a claim. The current government is very, very big on claims, so we make a claim. Most CEOs are male. I don't think it's a terrible claim, but 61%, so So let's do what we did before. What's the claim symbolically? And what's the opposite? Claim symbolically is what? Are we talking about means or proportions?
Proportion.
Proportion. So,
Most.
that's the claim. Most COs, not 61 COs. Most.
Oh, so it has to be greater than 5.
Yeah? This is the survey. This is the claim. So what's the opposite? Okay, which means that our null hypothesis is what? Equals 5, and our alternative hypothesis is p is greater than 0.5. So far, everybody should be with me. We should be golden. Yes? Yes. No. Objections? No. No objections. Okay. So, what's our test statistic? Well, our test statistic is right there. It says z equals to p hat minus p divided by p, q, n square root. Well, let's see what we have. Do we have p hat? Anybody? P hat?
It's 61.
61, yes. Or 0.61. How about p? We need p. So how much is p?
Just 1, right?
No. P is right here. Just put- So 61 goes in here, and this goes in here. Yeah, better marker. So 61 went here, and then the 50 came from there. What else do we need? We have p hat, p, we need q. How much is q?
39.
1 minus p. P is 50. So this is 0.5. Very careful. Which one's p hat, which one's p? What else we need? We need n. How big is n? And 706. Okay, so let's plug it in. So far, everybody's with me, yes? All right. So now we take our z, our test statistic, and it says it's 0.61 minus 0.5 divided by 0.5 times 0.5 divided by 706, and then square root it. Mind you, if you're writing things down midway through the steps, do not round the square root very much. Okay. I came out with a z equal to You get the same thing? Is anybody checking my work? I got it right? Okay. And so we arrive at this, and now there comes a question. Now comes a question. Is this rare enough to make us discard the null hypothesis? Right? Is this number suggesting, right, it's a z-score, is this number suggesting that the sample is so far away from the population mean, that the population mean we assumed right here, right, in h sub 0, to be wrong? Is this rare enough so we can discard this? Right? Rare event rule says if there's a really, really, really low chance of something happening, that's probably wrong. So is this suggesting, right, that the population is so far from the sample that the assumption that we made about the population is wrong? Right? What we do is we assume that h sub 0 is right, and we're trying to prove it wrong. So we assume this is right. And here we have evidence. Right? And we trust the evidence because we just collected it. So the question is our assumption wrong? And this is what we're going to start on Monday. Cliffhanger. Is this rare enough to toss this out?